Hello. Yeah, today I'm gonna read this one called How to Build Good Software. I think like in the past like 4 years or so, I remember like the CXC.gov is sharing this How to Build Good Software. It's an article, but when I go to that link, it's now the PDF. But I won't read the PDF though. So I just go back to like archive, and this is the article that I read in the box. And yeah, I'm gonna read this one. Okay. How to build good software. Software has characteristics that make it hard to build with traditional management techniques. Effective development requires a different, more exploratory and iterative approach. By Li Hongji. I'm not sure the pronunciation is correct. Li Hongji. It was published in 2019. So far, when I read in the box, I was enjoying it. Let's see is other profile still able to see. Okay. Why bad software happens to good people? Let me zoom in a bit. Bad software is one of the few things in the world you cannot solve with many billion-dollar airlines have fly such apps that are often inferior to those built by a group of students. Established taxi company in the world over have terrible pokey apps despite the threat they face from ride-sharing services, and painful corporate IT systems are usually project works, massive budgets, built over the course of many years. Whatever the cost of bad software is, it doesn't seem to be left off fending. Yeah, true. Surprisingly, the root cause of bad software has less to do with specific engineering choices and more to do with how development projects are managed. The worst software projects often proceed in a very particular way. Okay, let's read. The project owners start out wanting to build a specific solution and never explicitly identify the problem they are trying to solve. They then gather a long list of requirements from a large group of stakeholders. This list is then handed off to a corresponding large extended development team, who get to work building this highly customized piece of software from scratch. Once all the requirements are met, everyone celebrates as the system is launched and the project is declared complete. Yeah, without knowing the purpose, I think it's quite hard to build the successful software. The root cause of bad software has less to do with specific engineering choices and more to do with how development projects are managed. That's the highlight from the above one. However, though the system technically meets specifications, some issues are found when it is put in hands of actual users. It is slow, confusing, and filled with subtle bugs that makes using it an excesses in frustration. Unfortunately, by this time the external development team has been dismissed and there are no resources left over to make the necessary fixes. By the time a new project can be initiated years later, all knowledge of what caused this problem has left the organization and the cycle start over again. The The right coding language, system architecture, or interface design will vary widely from project to project. But there are characteristics particularly to software that consistently cause traditional management practice to fail, while allowing small startups to succeed with shortening budget. Reusing good software is easy. It is what allows you to build good things quickly. Software is limited not by the amount of resources put into building it, but by how complex it can get before it breaks down, and the main value in the software is not the code produced, but the knowledge accumulated by the people who produce it. Understanding these characteristics may not guarantee good outcomes, but it does help clarifying why so many projects produce bad outcomes. Furthermore, this leads to some core operating principles that can dramatically improve the chance of success. 1. Start as simple as possible. 2. Seek out problems and iterate. And 3. Hire the best engineer you can. While there are many subtle factors to consider, these principles found a foundation that let you get started building good software. Reusing software lets you build good things quickly. Software is easy to copy. At a mechanical level, line of code can literally be copied and pasted onto another computer. More generally, the internet is full of tutorials on how to build different kinds of systems using ready-made code modules that are available online. I think this is like 2019, so now it's like with the ChatGPT, I think it's make it more easier to copy paste. Modern software is almost never developed from scratch. Even the most innovative applications are built using existing software that has been combined and modified to achieve a new result. True. The biggest source of reusable code module is the open source community. Open source software is software in which code is freely published for anyone to see and use. Many of the largest contributors to the open source community are giant tech companies. If you want to use a state-of-the-art planet scalable database as Facebook does, just download the code of Cassandra that they open sourced in 2008. If you want to try out Google Cadillac machine learning for yourself, download the TensorFlow system published in 2015. Using open source code does not just make your application development faster, it gives you access to technology that is far more sophisticated than anything you could have deployed yourself. For the most popular open source code, it is even more secure as there are many more people paying attention and fixing vulnerabilities. This is the reason digital technology has made such rapid progress. Even the newest engineer can build upon the most advanced tools our profession has to offer. The advance of cloud services has taken reusability even further, offering the full use or even proprietary system for just a subscription fees. Need a simple website? Just configure one in a few clicks using a website building service like Squarespace or with a database. Subscribe to Badger One from Amazon Web Services or Microsoft Azure. Cloud services allow developers to benefit from specialization. The service provider handles the setup, maintenance, and continued development of reliable, high quality piece of software that is used by all its subscribers. This allows software developers to stop wasting time on solve problems and instead focus on delivering actual value. You cannot make technological progress if all your time is spent on rebuilding existing technology. Software engineering is about building automated systems, and one of the first things that get automated away is routing software engineering work. The point is to understand what the right system to reuse are, how to customize them to fit your unique requirement, and fixing novel problems discovered along the way. Software engineering is about building automated systems, and one of the first things that get automated away is routing software engineering work. This is a highlight from the above one. Software is limited by complexity. How useful a piece of software can be is usually limited by its complexity rather than the amount of resources invested in building it. IT systems are often full of features but are still hated by users because of how confusing they became. In instance, highly ranked mobile apps tend to be launched for their simplicity and intuitiveness. Learning to use software is hard. Beyond a point, a new feature actually makes things worse for users because the accumulated complexity starts to become overwhelming. For example, after serving as the head of Apple Media ecosystem for almost 20 years, iQOO was split into 3 different apps for music, podcasts, and TV show this year, as its feature had grown too complex for one app to handle. From a usability perspective, the limit is not how many features can be implemented, but rather what can fit into a simple intuitive interface. Even ignoring usability, engineering progress slows to a halt once a project becomes too complex. Each new line of code added to an application has a chance of interacting with every other line. The bigger an application's code base, the more bugs are introduced whenever a new feature is built. Eventually, the rate of work created from new bugs cancel out the rate of work done from features developed. This is known as technical debt and is the main challenge in professional software development. It is the reason why many large IT systems have issues that go unfixed for years. Adding more engineers to the project just add to the chaos. They started running faster in places as the code base keys over from its own weight. Building good software involves alternating circuit or expanding and reducing complexity. This is the main highlight from this. In such cases, the only way forward is to take a step back to rationalize and simplify the code base. The system architecture can be redesigned to limit unexpected interactions. Non-critical features can be removed even if they have already been built. Automated tools can be deployed to check for bugs and badly written code. Basics 1.6. Measuring programming progress by line of code is like measuring aircraft building progress by weight. Human minds can only be handled a finite amount of complexity. So how sophisticated a software can get depends on how efficiently this complexity budget is used. Building good software involves alternating circuit or expanding and reducing complexity. As new features are developed, this order naturally accumulated in the system. When this messiness starts to cause problems, progress is suspended to spend time cleaning up. This two-step process is necessary because there is no such thing as platonically good engineering. It depends on your need and the practical problem you encounter. Even a simple user interface such as Google search bar contains a massive amount of complexity under the surface that cannot be perfect in a single iteration. The challenge is managing this cycle, letting it get messy enough to make meaningful progress, but not letting it get so complicated that it began overwhelming. Highlight from that paragraph is like, that section is like, there is no such thing as platonically good engineering. It depends on your needs and practical problem you encounter. Software is about developing knowledge more than writing code. In software development, most ideas are bad. This is not anyone's fault. It is just that the number of possible ideas is so large that any particular idea is probably not going to work, even if it was chosen very carefully and intelligently. To make progress, you need to start with a bunch of bad ideas, discard the worst, and evolve the most promising one. A paradigm of visionary design goes through dozens of prototypes before landing on a final product. The final product may be deceptively simple. It is the intrinsic knowledge of why this particular solution was chosen over its alternatives that allow it to be good. This knowledge continues to be important even after the product is built. If a new team takes over the code for an unfamiliar piece of software, the software will soon start to degrade. Operating system will update, business requirements will change, and security problems will be discovered that need to be fixed. Handling this subtle error is often harder than building the software in the first place, since it requires intimate knowledge of the system architecture and design principles. In the short term, an unfamiliar development team can address this problem with stopgap fixes. Over time, though, new bugs accumulated due to the makeshift nature of the additional code. User interfaces began confusing due to mismatched design paradigms, and system complexity increased as a whole. Software should be treated not as a static product, but as a living manifestation of the development team collective understanding. The highlight is software should be treated not as a static product, but as a living manifestation of the development team collective understanding. This is why relying on external vendor for your core software development is difficult. You may get a running system and its code, but the invaluable knowledge of how it is built and what design choices will leave your organization. This is also why handing a system over to new vendor for maintenance often causes problems. Wow, this is literally insane true. Even if the system is very well documented, some knowledge is lost every time a new team takes over. Over the year, the system begins a patchwork of code from many different authors. It became harder and harder to keep running. Eventually, there's no one left who truly understands how it works. For your software to keep working well in the long term, it's important to have your staff learning alongside the external help to retain critical engineering knowledge in your organization. Well, that's true. Like if you lack banner big the staff, you might probably get like the rainy suffix. But if you need to if you have to add a new additional feature, have to maintain the staff, then I think it's really hard. Three principles for good software development. 1. Start as simple as possible. Projects that set out to be one-stop shop for a particular domain are often doomed. The reasoning seems sensible enough. What better way to ensure your app solves people's problems than by having it address as many as possible? After all, this works for physical stores such as supermarkets. The difference is that one is relatively easy to add new items for sale. Once a physical store is set up, an app with twice as many features is more than twice as hard to build and much harder to use. Building good software requires focus. Start with a simple solution that could solve problems. A well-made but simplistic app never has problem adding necessary features, but a big IT system that does a lot of things poorly is usually impossible to simplify and fix. Even successful do-it-all apps like WeChat, Grab, and Facebook started out with very specific functionality and only expanded after they had secured their place. Software projects rarely fail because they are too small. They fail because they get too big. What? Yeah, the highlight is software projects rarely fail because they are too small. They fail because they get too big. Unfortunately, keeping a project focused is very hard in practice. Just gathering the requirement from all stakeholders already create a huge list of features. One way to manage this load is by using priority lists. Requirements are all still gathered, but each are tagged according to whether they are absolutely critical features, high-value additions, or nice-to-haves. This creates a much lower tension planning process because features no longer needed to be explicitly excluded. Stakeholders can then more sanely discuss which features are the most important without worry about something being left out of the project. This approach also made explicit the trade-off of having more features. Stakeholders who want to increase their priority for a feature have to also consider what feature they are willing to deprioritize. Teams can start on the most critical objective, working their way down the list as the time and resources allow. We follow a similar process for all our most successful apps. Forms.gov.sg started out as manual Outlook macro that took us 6 hours to set up for our first user, but today has processed about 1 million public submissions. Data.gov.sg started out as a direct copy of an open source project and has since grown to over 300,000 monthly visits. Parking.sg had massive list of almost 200 possible features that we never got around to building, but still has over 1.1 million users today. These systems are well received not in spite of their simplicity, but because of it. Okay, 2. Seed out problem and iterate. In truth, modern software is so complicated and changes are so rapidly that no amount of planning will eliminate all shortcomings. Like writing a good paper, awkward early drafts are necessary to get a feel of what the final paper should be. To build good software, you need to first build bug software, then actively seek out a problem to improve on your solution. This style works simply as simple as talking to the actual people you are trying to help. The goal is to understand the root problems you want to solve and avoid jumping to a solution based on preconceived bias. When we first started on Parking.sg, our hypothesis was that enforcement officers found it frustration to have to keep doing the mental calculation regarding the paper coupons. However, after spending just one afternoon with an experienced officer, we discovered that doing this calculation was actually quite simple for someone doing it professionally. That single conversation saved us months of potential wasted effort and let us refocus on our project on happy drivers instead. Beware of bureaucratic goals. Masquerading as problem statements. Driver feel frustrated when dealing with parking coupons is a problem. We need to build an app for driver as part of our ministry family digitalization plan is now. Users are annoyed at how hard it is to find information on governmental websites is a problem. As part of the digital government blueprint, we need to rebuild our website to conform to the new design service standard is not. If our end goal is to make citizens' life better, we need to explicitly acknowledge that the things that are making their life worse. Having a clear problem statement let you experimentally test the viability of different solutions that are too hard to determine theoretically. Talking to a chatbot may not be any easier than navigating a website, and users may not want to install yet another app on their phones, no matter how secure it makes the country. With software, apparently obvious solutions often have faulty flaws that do not show up until they put to use. The aim is not yet to build the final product, but to first identify these problems as quickly as possible and as cheaply as possible. Non-functional mockups to test interface designs, semi-functional mockups to try different features, prototype code written hastily could have garner feedback more quickly. Anything created at this stage should be treated as disposable. The desired output of this process is not the code written, but a clearer understanding of what the right thing is to build is. Beware of bureaucratic goals, masquerading as problem statements. If our end goal is to make citizens' life better, we need to explicitly acknowledge the things that are making their life worse. With a good understanding of the right solution, you can start work on building the actual product. You start exploring new ideas and narrow down to identifying problems with your particular implementation. Being with a small number of testers who will quickly spot on the obvious bugs, but that needed to be fixed as problems are addressed, you can increasingly open up to a larger pool who will find more asterisk issues. Most people only give feedback once. If you start by launching to a large audience, everyone will give you the same obvious feedback and you will have nowhere to go from that. Even the best product idea built by the best engineer will start out with significant issues. The aim is to repeatedly refine the output, sanding down raw edges until a good product emerges. Even after all this iteration, after launch is when problems with a product matter the most. A problem that's happen only 0.1% of the time may not get noticed during the testing. But once you have a million users, every day the problem goes and result is 1,000 more angry people who have to deal with. You need to fix problem caused by new mobile devices, network outages, or security attacks before they cause substantial harm to your users. With Parkintos SG, we built a series of secondary systems that continuously check the main system for any discrepancy in a payment, duplicate parking sessions, and application crashes. Building up an immune system over time let you avoid being overwhelmed as new issues inevitably come up. Overall, the approach is to use these different feedback loops to efficiently identify problems. Small feedback loops allow for quick and easy correction but miss out on borrowed issues. Large feedback loops catch broader issues but are slow and expensive. You want to use both, resolve it as much as possible with type loops while still heavy while loops to cache and expect the error. Building software is not about avoiding failure, it is about strategically failing as fast as possible to get the information you need to build something good. 3. Hire the best engineer you can. The key to having good engineer is having good engineers. Google, Facebook, Amazon, Netflix, and Microsoft all run a dazzling numbers of the largest technology system in the world. Yeah, they famously have some of the most selected interview process while they competing fiercely to recruit the strongest candidates. There's a reason that the salary for even the fresh graduate have gone up so much as these companies have grown. And it's not because they enjoy giving away money. Both Steve Jobs and Mark Zuckerberg have said that the best engineers are at least 10 times more productive than an average engineer. This is not because good engineers write code 10 times faster. It is because they make better decisions that save 10 times the work. A good engineer has a better grasp of existing software they can reuse, thus minimize the bar of the system they have to build from scratch. They have a better grasp of engineering to automate away most of the routine aspects of their own job. Automation also means freeing up humans to work on solving unexpected errors, which the best engineers are disproportionately better at. Good engineers themselves design systems that are more robust and easier to understand by others. This has a multiplier effect, letting their colleagues build upon their work much more quickly and reliably. Overall, good engineers are so much more effective not because they produce a lot more code, but because the decisions they make save you from work you did not know could be avoided. This is true based on my experience. This also means that small team of the best engineers can often build things faster than every large team of average engineers. They make good use of available open source code and sophisticated cloud services and offload maintain tasks onto automated testing and other tools, so they can focus on creative problem solving aspect of the job. They They rapidly test different ideas with user by prioritizing key features and carry out an important work. This is the central thesis of the classic book, The Mythical Man. In general, adding more software engineer does not make a project go faster, it only makes it go slower. Building software is not about avoiding failure, it is about strategically failing as fast as possible to get the information you need to build something good. Smaller team of good engineers will also create fewer bugs and security problems than larger team of average engineers. Similar to writing an essay, the more authors there are, the more coding style, assumptions, and costs there are to reconcile in the final composite product, exposing a greater surface area of potential issues to arise. In contrast, a system built by a small team of good engineers will be more concise, coherent, and better understanding by its creator. You cannot have security without simplicity, and simplicity is rarely the result of large-scale collaborations. The more collaborated an engineer effort, the better the engineer need to be. Problems in an engineering code affect not just his work but that of his colleagues as well. In large projects, bad engineers end up creating more work for one another, as error and poor design choices snowball to create massive issues. Big projects need to build one solid, reliable code module in an effective design with very clear assumption laid out. The better your engineers, the bigger your system can get before it collapses and at its own weight. This is why the most successful tech companies insist on the best talent, despite their massive size. The hard limit to a system complexity is not the quantity of engineering effort, but its quality. Okay, conclusion. Good software development starts with building a clear understanding of the problem that you want to solve. This lets you test many possible solutions and converge on a good approach. Development is accelerated by reusing the right open source code and cloud services, granting immediate access to established software systems and sophisticated new technology. The development cycle alternates between exploration and consolidation, quickly and messily progressing on new ideas, then focusing and simplifying to keep the complexity manageable. As the project moves forward, it gets tested with successively larger group of people to eliminate increasingly uncommon problems. Launching is when the real work ramps up for good development teams. Layout of automated systems should be built to handle issues quickly and prevent harms to actual users. Ultimately, while there are infinite intricacies to software development, understanding this process provides a basis to tackle the complexity of how to build good software. Okay, that's all. I will share the link in the description as well. You can go read yourself as well if you want. Thank you.